learning about RF links, building a circuit, and more importantly, perhaps discussing the theory of how it is that, a bit of code, a message gets transmitted from one of these transmitters to one of these receivers. And that's a very important process because it's everywhere in our lives. Your mobile phone works on this principle. Your radio in your car, the satellite transmissions for both, satellite channels or satellite phones. And it's something that's rather simple. For the basis of it is we generate electromagnetic waves. Electromagnetic waves are everywhere. Light is electromagnetic radiation. So the sun bathes us in electromagnetism. We ourselves reflect it around, and all it really is charges. So electrons generally, although you could have positive charges do the same thing, are bouncing up and down or being shuttled forward and backward. Now this happens inside like atoms when electrons jump up and down from shells, or you can make it happen like with oscillating electric current. So an example of like how I could generate light if I was Superman would be I'd wave my hand like this at you, but instead of like doing it a couple of times a second, I do it 400 trillion times a second. In which case you would see red light coming from where my hand is. And if I did it at like 7, it'd probably be purple light. So if it's that simple, if we create electromagnetic waves simply by shuttling charges forward and backward, then creating electromagnetic transmissions should be pretty easy. And I've got a diagram on the board here of what effectively goes on. So this here looks like an electric motor, and it could be a common AC motor. And all we do here is we could get charges to be aligned in one way then another way. So effectively we've got some plus charge over here, some minus charge, and the electric field goes from plus to minus. But then we can switch it around and have pluses down there, minuses up there. Then we change the direction of our field to plus and minus. And if we do this all the time, effectively what we're doing as time goes on is creating electric fields that go up, down. So these are electric field, and electric field is the vector. You don't need to know what a vector is, but so all you get is this kind of wave of propagating electric field that go up and down. And some of you have guessed it, but what this equates to is like a sinusoidal wave. So if we start up, we'll go down, then up, then down, then up, then down, then up, down, up. We join these, and there's our basic electromagnetic wave. So if on the other side we were to build a device that looks really similar to our motor over there, we would be able to capture this wave and reproduce it. So if we could do something like similar length, similar dimensions, and it goes through a variable capacitor, and then into some kind of an inductor, and on the other side we'd have another inductor. This would effectively be an amp. And so what you would get here is this electric field arranging electrons in here and driving them exactly the same way that these guys were driven. So you have maybe sometimes hundreds of kilometers away a signal going out in these waves like this, and another circuit similar to the one that transmitted them, picking up that signal, amplifying it, and translating these guys into pictures or sounds or whatever. And the next question you probably logically have is, how does this wave like carry information? Well, that's where letters like AM and FM come in. So AM would be amplitude modification, and amplitude modification works a little like this. You essentially take these waves and you lower their amplitudes. So when you lower an amplitude of a wave, that becomes a zero. this wave a 1 and that wave a 1. You've also heard of FM. FM works a little like this. If you get a wave tightly bunched up, that's a 1. Loosely is a 0. Tightly bunched up is a 1. Loose is a 0. Tightly bunched up is a 1. So it goes like 1, 0, 1, 0. So effectively, what we can do on this end is modify these waves a little bit so that our antenna can pick it up, and then we can translate this modified wave into a chain of zeros and ones. And at the end of the day, any message that we send via digital circuits is simply going to be a bunch of zeros and ones, which is read by a program that reinterprets that into computer code, data, and so on. In this particular circuit, uses something called OOK, which is on-off keying. On-off keying is very, very similar to AM, actually. So it effectively has little tiny waves for zeros and big tall waves for ones. And unlike AM, I think on-off keying uses square waves, so it's actually going to look like, but it's effectively the same thing. So what else is there to know? Oh yeah, so the only complicated part of this, the only part of this that's actually difficult, that I myself can safely say I don't really understand, happens at this stage. As I said, radio frequency is ubiquitous. These waves are absolutely everywhere, and they interfere with each other all the time. So if this very simple circuit that you could see, technically a message sent from one pin is replicated in another pin. If I was to try to read that message straight away as it's replicated, I would get a useless circuit because there'd be too much noise. So all of this is, without mathematical algorithms that compute them, not very useful. Right here, I can call this a black box. Right here is where mathematical geniuses come up with all kinds of esoteric maths and equations to process these waves that are then put into programs. Some of these are even adaptive. So you send an initial test signal, and then an algorithm here is created by the computer that will filter out all the noise to find the signal. So yeah, this bit is fairly advanced, and this is why when we build Arduino circuits, we're going to be using a library. And that's what the library does. It filters through the noise. And yeah, that's it. That's how radio waves are transmitted. I hope you found it interesting. Now let's build a circuit.
So, here we got our two Arduino boards that are going to set up our wireless modules, and hopefully by the time I'm done, I'm going to have them powered off independent power supplies so that you can just see, transmission and receiving circuits functioning without any wires in between them. Our two modules right here have been upgraded a little bit. These wires dangling off are actually antennas. Both circuits have a little ANT slot, and you basically solder in an antenna. Now there is a bit of a science, because initially I've just soldered some wires on and they did not work so well. They worked better than without any antennas, but you have to pick specific lengths of these wires. So one is straight. The one in the transmitter is straight, the other one is curled. And in terms of what length code. First, we're going to look into the transmission code right here. And the first thing we do is we use this virtual wire library. Now, as explained in the theoretical section, you cannot simply send messages or ones and zeros between these modules. They need to go through a mathematical process that clears out the noise. And this is quite complex, but it's not something we're going to get into here. So all that this code does is we select a pin for our button, we set it as an input, we turn push-to-talk communication on, that means that you cannot listen and talk at the same time. In other words, that's how these modules work. It's sort of like walkie-talkie communication as opposed to telephone communication. So like you're either transmitting a message or receiving a message. Pin 12 sets the transmitter pin, and this here is quite an important thing. We've selected 4,000 kilobytes per second. We could select 3,000, 2,000. The lower the transfer data rate, the higher the range of the antenna. So this is really not going to matter for our little experiment, but once you move to cars and quadcopters, it'll be worth experimenting with. So this is where the action happens if digital read button is high. So if the button is pressed, send a message that says X. Now note, I just wrote Merry Christmas here. I could have left it blank. Just for fun. So you send out a message X once you push the button, and that piece of code there, that function sends the message, and it waits until the message is gone. Then you wait 2 seconds, because it's going to take roughly that for the light and sound show to happen. So this is the receiver code. It's a little bit more complicated. So I'm using also the virtual wire library. I'm using 3 pins. This is like the standby LED. So once we upload this, the red light should come on. And yep, those pins are set as output. Push-to-talk communication set as true. 12 is the receiver pin. You got to use the same number of bits per second. And this basically initializes the listening for the signal out there. This piece of code specifies that messages are 80 bytes in length. Now, 80 bytes is like 80, pretty much works out to 80 characters if you're writing text. So this is the code. If a message is received, so this function there basically checks if the message is received. Now this BUF0, it checks the first character of the message. So if I put BUF2 there, it would be the third character, 0, 1, 2. So as I said, I sent a message that's X, so the only character in there is the first character, and that's X. So if X is received, turn the standby light off and run this loop that alternates between LEDs turning on and buzzer turning on. So look a bit like a siren. Now, and else if the letter in the message is not X, so the message would have been received, but if the message was the wrong one, then keep the red light on and do nothing. So that's pretty. Alright, one very important note, for these code to work, and Arduino will give you an error if it doesn't, but this virtual wire library needs to be kind of highlighted in orange. And in order for you to know that you have it, I think, yeah, under Sketch, it's going to exist in your libraries. So in order to make this happen, I'll give you a link in the description of the video, and you can go to the website and just drag and drop the virtual wire folder into your Arduino libraries folder in your C drive. So let's upload these. There's nothing interesting going to happen here except we're going to get a double blink on our Arduino that tells us the code's uploaded. And with the receiver, we are hopefully going to get that red light to turn on, which will indicate that the circuit is in standby.
these tutorials comes with a downloadable PDF manual and the finished program. The PDF manual usually contains more information about the program and step-by-step instructions that are illustrated on how to build a circuit. And the downloadable program will be sure to save you some time. So hop on over to robotics.com.au